they go through the 8 holes, 2 lumps per weight, so we can pick up figures and so on. In a moment I'll show you the wire rope will come down this tube. Connects onto a little slider in there that goes through this slot. Okay? There's 2 bars that go through that slot. And if you look on the top one, you've got this crown plate on the side, that creates these limit switches. They're just sort of on-off switches. You tell that box. I need to find that nice wherever it is. Okay. The outermost ones reverse, and the inner ones actually accelerate up to a higher speed. So effectively it's like a lift control, very similar. You approach the floor slowly, and that will say stop on the floor, and then this one is an accelerator. I've actually been doing quite a bit of just manual control. Alright, so hopefully this goes in here. Yes, it does. So the number of students who've been worried about the weight of this
motor 也是直接放在上头。对啊。我操，真的？对呀，我想这个是放着的吗？这没想放。How can you say any support? 就是整个东西。I didn't know the motor didn't get any support. Yeah, it's mounted on there, man. Oh, 不是。What?
The grub screw. I think we should stuck with the clamp attachment we have. This one, it's only grub screw.
Okay.
Grub screw breaks, wire goes.
Makes sense.
Which is sort of our fault. But, and about probably half the winches have got mechanical interference because they're not restrained, or quite a few groups haven't restrained. When I say you, I mean students. Not necessarily you. Students are not restraining the end movement of this worm wheel, and he just climbs up, gets pulled by the worm, and climbs up over the worm and just jams. So that's pathology number 1. Other ones, so much slop that the gears move around and they just interfere with each other.
And how many completed everything?
Have we?
How many loops completed like the 250 kilograms?
2. Okay, 2 have actually lifted, well, none have lifted to the full height.
For now.
Not yet.
The reason I know you won't do that is because what you should have done is not had a drum at all. You have to use this, but I did say you turn it to sport. So you can have no drum at all, so better than that.
Yeah.
Right, so this is all tight. Double check. That's tight. A couple of groups haven't bothered tying all their nuts together and turn the pump on winch on, so like this. Damn solid on those devices. Okay. Let me just get this tight. So yeah, you get the idea, these go in the gap. The short ones, and they'll pick up this way. Alright, okay, so we go back upstairs. During testing, if you stand basically behind like that line, as it were, the threshold, just see the most important safety thing is distance. You're not anywhere near the thing; it's not going to cause a problem. Alright. So the first thing we'll do, we'll just sort out assuming it works at all. there's jam or something like that, don't despair.
它像好容易掉下去，我操！
This is how I cut the fingers off. Getting there, isn't it? Once it grabs hold. There we go. Right, now what's going to happen, I've not been able to trick this box into measuring what seconds or what hours. So it's still stuck in kilowatt hours, so there's no point measuring energy because we won't get to a kilowatt hour, nothing like it. So I will hollow out an instantaneous power, which you're going to write down in your logbook, one of you. So obviously for 50 kilograms I will say X kilowatts, right? Alright? As long as one of you's got it in your logbook, that's alright. Okay, so just write down 50. So for 50, so we're lifting 50 kgs. Alright, and here we go. So it's slow at first.
Oh my god.
Don't worry about that. That's just the wire rope destroying
That's easy, man. Too easy first. So that's 150.
This is 100. Two weights. Ready?
Yeah. Oh my.
We'll do 1.5. 1 kilowatt.
它1 kilowatt 指的是什么呀
It's quite a lot.
Instant
The audio delay.
Instant power。它不是 motor 不是固定的吗？它调。
The gears run together. How far away am I?
A couple of centimeters. Bit more.
It won't quite go down. I'm just trying to keep that rope tight. I didn't succeed.
No. No.
Did you see that drum move?
First, yes, and it.
Okay. Never mind. Okay, let's.
Come on.
Literally just, whenever you have anything seized, try and do forward, reverse, yeah? It's not going to lift too heavily. We might be able to get something with it. I'll go right down. Well, I won't go right down, will it? It's not like that, is it? Try and go 100s. I can continue, but I don't think it's going to do it, is it? But that's a good winch, right? Let me just get the thing there. I'll explain. Basically, Peter and I have made a mess of it. But I don't think this isn't why it's going down. Essentially, we've got the contact pressures on these gears too high, so they're seizing. So the people who've done 250, they've virtually got no. They've reduced this diameter, reduced the torque, and hence given the gears a chance. But what you're doing, putting gear bearings into here, is the obvious thing. Having a steel housing, you didn't probably need that there. You could have had bearings all the way along, and all the way into the drum, and just had this as a drive spool. So basically, what you should have done is extended this. Because obviously at the moment there's actually a bending moment being imposed onto this shaft, whereas really been better if it was just a pure torque, which is what this housing now is. Is obviously much stiffer than this member, merely because it's a few millimetres bigger in diameter. You might as well extend it right in. What things I don't like, it's not good practice to rely on, because you've got significant thrust load on that shaft because of the friction from the worm. It's not insignificant. Even if Peter and I got this right, it's beautiful hydrodynamic contact. A worm will still push that worm wheel in and out quite a lot. And it's not good practice to rely on a press fit to take that, because particularly in a gearbox with an aluminium housing, once this gets warm, it will expand off that bearing and the whole thing will just move. And that would be...
It would be better to have a step in the body.
You need a step in the body, yes.
Because we had one, and Judah told us to do like that.
Well, what do you think? Do you think they were right? I mean, you see what I'm saying? I think a press fit is a risk for a student, because, in a sense, you're not a good enough machinist. Okay, if you've managed to do it, 5 times out of 10 you won't. Because in a sense you're not good enough. Say, okay, you got it right, but it's not a good choice. It's not a good defensive design. But when you write your reports, the bit at the end, the discussion, you should look at your design and think, okay, what did we do wrong? And be quite say, well, okay, that isn't really very good on reflection. And what did you do right? I mean, you've made it well. Because essentially, unless you make them well, they won't. What I'm a bit concerned about is that what happens, what stops this pulling in this direction? You're saying, because obviously at the moment, if I get hold of that, why can't I just pull this out?
The drum shaft?
Yeah, I mean, okay, what is this bearing here? Is that a needle roller?
Yeah, machine one.
So that will just allow inflow, won't it? So what stops this whole thing moving along?
It's because they're all connected.
All right, no, but I mean, if I get hold of this shaft, I can just pull this along. This bearing will stay still, correct? Won't it just slide?
It's attached to the...
I can see that, but this, you've got no axial constraint. Won't it just sort of close up and hit on there?
But like there's a screw, you don't actually see it.
No, I can see that your drum is part of the shaft, if you like.
Okay.
So if I get hold of this, you must have noticed that a needle roller bearing just falls apart axially. So is it just that it bumps up against there?
Yeah.
Yeah. Okay. Well, that isn't good, right?
We didn't know
all
it
you
was
need to
sliding like
all
that.
you need to do. I mean, if you put a clip in, that isn't good either, because really the clips aren't strong enough. But at least you have constrained axial constraint. I mean, what probably you need to do is, funny enough, move that. Have this bearing bigger, have much bigger than, or the same size as this ball, whatever it was, 25 I think. So get a 25mm bearing, you've got tons of room, look, you could have a 50mm bearing. And then have a shoulder on the shaft on the other side. Yep. Hold the bearing as you've done with this little thing up against the step, so the outer race is constrained, and then have a bolt from this side rather than that sort of bolster as you've done, which is okay. It's just a bit It's effectively what I did on that design. It's pretty, I haven't got the drawing for it really. Let's have a look at this one. Again, I don't mind the end stop. It's actually okay, because fundamentally, as you rightly surmise, you've got force in this direction. So in fact, if all you just have is a stop against, which is, the stop here is no good, because you do have working forces in both directions. When that worm reverses, it will have pulled both ways, quite a lot as well. But here, fundamentally, the only time that stop would ever hit is when you assemble it. And the rest of the time, it's pushing in this direction. Now, obviously, again, for a winch, I wouldn't do that in a commercial winch, because I'd expect some idiot to put the wire rope the wrong way around. So I'd make sure that that worm could push and pull, which is actually not that easy. I mean, probably in reality, what you do is you'd have a bearing over here. The reason I didn't do that, I was concerned with you boring down, although you have actually done it, down a deep hole. Yeah? I was concerned with, if I have bearings both sides, then students are having to do sort of deep boring operations, which are not easy. I know you've done it here. But yeah, most worm boxes have bearing supports both sides, because the worm is, when it's pushed in this direction, the line of action of force goes through the bearing, so it hardly twists. But when it's the other way, it would sort of tip down quite a lot as well. So you then want a bearing that side. You've got seal here, seal there. Yes, I suppose the
tapered roller.
What? Okay, that's a taper roller, and
That's a ball
this is ball bearing. So you've controlled that length of that spacer, so that ball bearing doesn't end up taking the load. Okay, that's good. Perfectly okay. Again, what probably I'd do here, rather than that there, this is I think where a circling probably is reasonable. You'd move that seal back a bit, have a bit of space, but just put a clip in at that point. Now, will that stop that thing falling out? No, it won't. You don't really restrain that bearing. So what you could have done is have another step there. But it's all right here, stop. It's not a very good drawing, guys. This view, you only need two views. But if I make that bigger, sorry, this one bigger, I don't need this one, do I? Because that will be as big as that. Lose it. Similarly, these scrap views, you know, again, if I have 1, 2 views, 9 balloon there, 3, so that point of those screws, not very immediately obvious, there, 2, there. So if I have a drawing where I don't need the need for lose it, and orthographic drawings, they line up, so those 2 views only, I will mark the drawings. And yes, definitely change. Things like this, it's not very neat, is it? At least you haven't got some great big long ISO description. Not much of a drawing number. It's meant to be a unique identifier. Think of your national insurance number. That is a unique identifier of you. That, you know, Rolls-Royce will have literally tens of thousands of drawings dating back to 1920. And they want a unique number, or at least reasonably unique. And this is a little bit, you know, it could be tidied up a little bit to reduce the size of the lettering. Try to get the spacings the same, rather than sort of whatever that is. All right, so good. So, as I say, what Peter and I did is that I thought he checked the contact pressures, and he thought I had. So the thing is that we teach you the Lewis formula. The Lewis formula is okay for spur gears because essentially they fail quite often due to the tooth snapping off. But in the case of, that's where you have a rolling contact. But as you go to a helical and you increase the helix angle and eventually become a worm, because this is a helical gear with a single tooth gear, you gradually, progressively have more and more sliding. So you go from a rolling contact to a sliding contact, and then really you're asking for a rolling contact. We can have an elastic hydrodynamic film, very, very high contact pressure. As we go to a sliding contact, we need an oil film, a full hydrodynamic film. Much lower contact pressures are possible. So, just bad design. What I did, if I was designing this professionally, phosphor bronze, some hardened steel. That's how they do the worm wheel drives. But I didn't think you could machine even EN242. So the average student will struggle with that. And phosphor bronze is expensive. So we went to a soft steel, and it was a bad choice. It's not something I'd ever do professionally, but so that's the excuse that we should have done the contact pressures, and that's what's happened here. Your Winch would have probably lifted 250, because although I warned you about this shaft, you haven't got a problem anyway. But even if you just have a simple shaft overhang, it would have yielded once and then probably work hardened, wobbled about a bit. But because in this design you can run to a factor safety of 1. Like a TV shoot. Yeah. And I mean, they design things to factor safety sometimes. Okay. So let me just take the whole thing apart. I've got everything. With that. We've got a 14. That's a 10.
Girls, you make the rockin' world go round. Now I've got monsters on bones, I've got stiffness in my bones. Ain't no beauty queens in this locality. No, but I've still got my pleasure. Still got my greatest treasure. Hey, big woman, you gon' make me dance. Whoa, I know. Won't you take me home tonight? Whoa, down beside that red light. Whoa, and you give it all you got. Fat bottom girls, you make the rockin' world go round. Fat bottom girls, you make the rockin' world go round. Get on your bikes and ride. I want to ride my bicycle, bicycle. This is the real life. This is just fantasy. Oh, won't you take me home tonight? Whoa, down beside that red firelight. Whoa, and you give it all you got. Fat bottom girls, you make the rockin' world go round. Fat bottom